If you're building a second brain or an autonomous agent, and I hope you are, sooner or later, you need a place to see it running. Not a chat window, not a log file, a dashboard. Some people call it a command center. I built one for JARVIS. 8 tabs, 5 scheduled jobs, 2 wikis. Yours might look differently. Different tabs, different priorities, different fonts, different design. This video is about what one command center actually does, why you'll probably want one, and what the moving parts look like in one real implementation. At the end, we give you 5 principles we have learned so far in creating our second brain. We hope to inspire you to build your own. Here's the JARVIS architecture, 6 layers, for you at the top, down to the bare infrastructure. Remember, this is a work in progress, and we foresee further development as we continue to build our second brain. The layer we care about in this video is the second one from the top. I call it governance, because that's what it does. It lets us see what's running, steer what happens next, and catch problems before they compound. We're going to walk through parts of the command center: dashboard, feed, scheduled, skills, 2 wikis, and a crawler, so you can see how it feels to have one and decide what you want in yours. Here's the problem you need to solve. Once your AI starts running on its own, skills firing, memory updating, scheduled jobs pulling new knowledge, how do you see any of it? Most people don't. They prompt, check the output, maybe tail a log file. That doesn't scale. A second brain continues to evolve like your own brain. It continues to learn new things, consolidate knowledge, delete things that are not longer valid, and modify other information in its memory. Therefore, it is likely that our mechanism to see inside, our command center, is likely to evolve as well. Here's something to think about. When you have a system of systems, you don't need better chat. You need a cockpit, a decision surface. That's what a command center is. Until you have one, every additional agent you add is just another black box. This dashboard shows what's on my turn, what's on Claude's turn, completion rates, and tasks by domain at a glance. The feed tab, Kanban board, but notice what's not here. No pull requests, no branch names, no code diffs. You're managing goals, not terminals. Plan Mediterranean cruise is done. Create workout plan is on Claude's turn. Analyze portfolio is waiting for me. That's the right abstraction level. 5 system automation jobs. All healthy, all running. Weekly knowledge update checks designated YouTube channels every Sunday at 2 a.m. Weekly documentation crawl pulls the latest Claude code docs from Anthropic using Playwright. We will, of course, add to this list as our ecosystem dictates. Weekly Wiki reindex rebuilds the full-text search index after everything else finishes. Weekly investment update checks Chris Vermeulen's channel and syncs transcripts. And the big one, daily market analysis, runs every weekday at 9 a.m. using the Agent SDK. Not a shell command. Claude spawns as a subprocess, reads the asset revesting methodology from the wiki, runs the price tool, and writes a real analysis. Look at the last result. SPY and QQQ both in stage 3 distribution with RSI above 83. Real intelligence automatically. 2 kinds of scheduled work. The mechanical tasks, reindex, crawl, check for videos, run as direct function calls. No reasoning is needed. Intelligent tasks, market analysis, investment synthesis, spawn Claude code as a CLI subprocess via the Agent SDK. Full JARVIS context, wiki access, skills, memory. Cron handles when. The Agent SDK handles thinking. Now, the knowledge layer. Claude Code Wiki. Hot cache. Carpathy's LLM wiki pattern. 500 tokens of recent context loaded every session start. The stats? 134 videos in the system at this point. Some have not been processed yet. 39 wiki pages, 10 concepts, 4 experts. 135,000 words synthesized from the YouTube videos across 4 expert channels. Not stored, synthesized. We asked Claude to find what all 4 experts agree on and produce consensus pages. The expert consensus page alone is 15,200 words. The Tech Stack 2026 page is 7,800 words. The beginner expert roadmap is 9,600 words. Every page cross-links to related concepts with wiki links you can click through. I type hooks. 8 matches instantly. Snippet highlighting shows why each page matched. Debugging and productivity. Hooks not running. Context rot, the Python implementation. Carpathy's wiki, session hooks. SQLite full text search, BM25 ranking, Porter stemming, 50 milliseconds. And separate from code search, 733 code blocks in their own index, searchable by language. 2 wikis, 2 domains. Claude Code Wiki holds what I'm learning, AI techniques. Operations Wiki holds what I'm doing, right now, investments, for example. 5 pages synthesized from Chris Vermeulen's methodology, asset revesting, the 4-stage market model, my 14 ETF universe with rotation rules, technology sector specialization, and Vermeulen's latest weekly market analysis is constantly being added to the mix. Click into the 4-stage market model. Stage 1 accumulation, Stage 2 markup, Stage 3 distribution, Stage 4 decline, with 150-day SMA rules, JARVIS composite scoring, and common mistakes. This is synthesized from 6 asset revesting documents totaling 600 kilobytes. Same search, same wiki links, same infrastructure, different domain. They never cross-contaminate. We have seen how we can add knowledge to our system through using the channels of YouTube experts. We also can extract knowledge in other ways. We use 7 crawling strategies. We can scrape static web pages and recursive ones with depth and domain limits. We can use sitemap, accept RSS feeds, digest PDFs. We can utilize 2 playwright-driven variants for JavaScript rendered sites. That JS badge means headless Chromium renders the page before extracting content. Using all of these mechanisms, we can constantly add more knowledge to our knowledge bases and our wikis. There are 2 distinct mechanisms to crawl page. Static pages can use a simple, straightforward technique because the words are embedded in the HTML. So any of the static HTTP sources can be accessed directly by simple extraction techniques that don't require a lot of resources or execution. The information is embedded directly in the web page, so there is nothing to create when the web page is rendered in a browser. Therefore, in static pages, the information, the scripts, are straightforward to access. However, there are many web pages that use JavaScript, and the script itself is not rendered until the JavaScript runs. If you try to scrape those pages with one of the static page techniques, you will return an empty script. A technique like recursive JS will execute the embedded code in the pages through a headless browser, and then scrape the resulting pages, which now have the scripts. In our example, before we used the static process and got back an empty set, no words at all with pages like Claude Hook's documentation. Recursive JS, however, returns the entire Claude Code Hooks reference, 13,930 words in 3 seconds. It lands in the Wiki raw folder, and the next reindex makes it searchable. Crawl and save, and it's in the wiki. The weekly reindex picks it up automatically, or you run the reindex manually if you want immediate results. JARVIS has a skills browser. Every Claude Code skill is visible and editable from the UI. You can browse by category. You can read the full markdown. You can make edits that take effect immediately. When JARVIS encounters a task type, it picks the skill. Since skills are such valuable resources to complete almost any complex or complicated tasks, the ability to browse them and edit them directly is almost indispensable in a second brain. Now we will look at some of the lessons we have learned so far in developing JARVIS. From developing JARVIS to our Phase 6, we have discovered 5 design principles that you can utilize. Principle 1. Surface decisions, not data. Every tab asks a question. What's my turn? What's running? What do I know? Where did it come from? If a tab just shows information without implying an action, it doesn't belong here. Principle 2. Governance, not micromanagement. I don't watch every tool call. I watch completion rates and scheduled job health. The daily market analysis ran at 9 a.m., read the wiki, ran the price tool, updated the hot cache without me watching. I see the result when I open this tab. Principle 3. Knowledge that ages is knowledge that dies. The crawler plus the weekly cron plus the agent SDK synthesis is a self-maintenance loop. Every Sunday, 5 jobs run. YouTube channels checked. Documentation recrawled. New Vermeulen videos analyzed against my methodology. A wiki frozen on day 1 is worthless by day 90. Principle 4. Separate learning from doing. Claude Code Wiki holds AI techniques. Operations Wiki holds investment methodology. Same infrastructure, deliberately partitioned. Investment insights don't belong in a page about RAG strategies. Cross-contamination rots both domains. Principle 5. Everything you see is revisable. Every page is editable. Every scheduled job has a Run Now button. Every crawl has preview before committing. Every search result links to the source page. A governance layer that's read-only is still a black box. This is the current architecture of JARVIS, and we believe it has been developed enough to share some of the lessons we have learned with you. Although we did not see every detail of JARVIS as it moves forward every day, we were able to share some principles that you might consider in developing your own second brain. That is the purpose of this series, to help you move forward in your own development. It is not to duplicate exactly what we have done, but to use these teachings as a reference point to help you brainstorm your own ideas and desires. This system keeps growing. The Claude Code Wiki started with 15 videos. Now, we have many more and growing. The Operations Wiki started empty. It already has 5 investment methodology pages and daily market analysis running automatically. We are looking at possibly adding some shorter-term investment methodologies to the system. However, even with such an addition, the architecture doesn't change. What changes is the scope. More sources, more domains, more synthesis, every week. Build a solid foundation for your second brain, and it will serve you well as you grow it to be perhaps your most valuable resource. If this is the kind of content you want, not here's how to write a hook, but here's the governance layer that keeps an AI system alive at scale, hit that subscribe button right now. Like this video so more builders can find it on YouTube. Share it with someone who's drowning in terminal tabs. And ring that notification bell so you don't miss Phase 7, where we hand JARVIS the keys to improve itself. As we mentioned before, the command center we are creating for JARVIS is not something you want to just take and replicate. That is not the purpose here. We want you to learn from us, to use the concepts and principles we present in our videos. You can get specific how-to information directly from any LLM, but it is the experiences and lessons we learned from actually building systems like JARVIS that we think are valuable and worth your time. So we hope you be back with us for Phase 7 in our development of JARVIS. Also, consider viewing some of our other series that try to teach lessons and principles that can help you better understand how best to utilize AI in your personal and business lives.